Good evening. Now we will have second video, that is on clauses of IS 456. So name already we have seen, plain and reinforced concrete, code of practice. Then effective span. So we have first simply supported beam. So in simply supported beam, we have, that is effective span is clear span plus effective depth. So two criteria you can see over there, that is clear span plus effective depth of slab or beam. For both we have same, or center to center of support, whichever is less. If I will draw a beam, and then we have, this will be clear span between the supports, and then we have center to center. So if we have B1 width will be for this, B2 will be for this, then we have clear span plus B1 by 2 plus B2 by 2, or clear span plus effective depth D. So we have, this will be first we have to consider, and then we have to check for second. So this already we have seen. Then we have second, continuous beam or slab. Now when my width of support, so width of support less than clear span by 12, then we have to use criteria that is of simply supported. Criteria that is simply supported. That means clear span plus effective depth or clear center to center distance. But if that is greater, then we have for end span with one end fixed and other end continuous, or for intermediate span, because end span fixed and other continuous, and for intermediate span we have same condition, and it will be only clear span between the support. Means as we have seen over here, that is, this will be clear span, and that will be, so in this case we have clear span. Now when we have for end span with one end free and other continuous, one end free, other continuous, means we can have, so this span, this way. So one end continuous left side and other end free. Then we have the effective span shall be equal to clear span plus half the effective depth of the beam or slab, or the clear span plus half width of the continuous support, which is less. Clear span plus half the width. We have width on one side only. On this side we have. So same only we are going to divide it by 2. Same as simply supported. So clear span plus B1 by 2, or clear span plus D by 2. B2 by 2 will not be there. We have support on one side only. And then third, that is of roller or rocket. So we are not concerned with this. And then for cantilever, the effective length of a cantilever shall be taken as the length to the face of the support plus half the effective depth, except where it forms the end of a continuous beam where the length to the center of support shall be taken. So we are interested, that is effective length of a cantilever is clear span, which is up to the face of the support plus half the effective depth. So whatever here we are considering, only one criteria of that we are considering here over here. So clear span plus half the effective depth. So if we summarize, then we have for simply supported, it is clear span plus B1 by 2 plus B2 by 2, or clear span plus effective depth, whichever is less. In second, that is for continuous, we are to first support less than B by 2. So we have same. And when we have support greater than B by 2, then we have for end span with end fixed, end span with end fixed or intermediate span. End fixed or intermediate span. Intermediate span. So effective span is clear span. And now if we have, that is one end continuous and other free, then we have clear span plus B by 2 or clear span plus D by 2, whichever is less. And third, we have cantilever. Cantilever. So we have clear span plus D by 2. So we have to keep in mind effective for these three. Then moment and shear coefficients for continuous beam. Now most important in this, when we can apply this. So these two conditions are most important one. That is minimum 3 spans are required. Minimum 3 spans are required. So keep in mind, this is most important one. And the second we have, that is, you can see this, which supports substantially uniformly distributed loads over 3 or more spans, which do not differ by 15%. First is 3 or more spans, so minimum 3, and which do not differ by more than 15% of the longest. That means shortest span should be greater than or equal to 0.85 into longest span. This is most important. Shortest span is greater than or equal to 0.85 into longest span. So automatically all are within 15% of the longest. And the bending moment and shear force design may be obtained by using table 12 and 13 respectively. For moment at supports where two unequal, this is again most important, when we have two unequal spans meet, or in case where the spans are not equally loaded, the average of the two values for the negative moment at the support may be taken. So we may have different values, and then we will consider it that will be equal to M1 by 2 plus M2 by 2. So we are going to take average of the two. So condition, try to understand this. Suppose we have this will be 1, and then we have this will be second. And if load we have on this side is 20 kilonewton per meter, and on this side we are being with 18 kilonewton per meter. Now let this will be 4 meter, and then 4 into Suppose 0.9, this will be 3.6 meter. Then we will find moment due to this. So if I will say this will be A, B, this will be C. Then moment they are mentioning when are not average of the two for the negative moment at support. So we have to take it as MBA plus MBC by 2. Average we have to consider in this case. These are given on page number 35. Then we have these values. Now try to understand this. So I will just draw it. So we have one in exam orals. They may ask you, draw the diagram and show the values. So we should be in position to show it. So we have near middle of end span. So we are with near middle of end span. So these are span moments. So near middle of end span. So I will just change the colors. So now first we have that is for dead loop. Now with middle of end span. So this value is 1 by 12. We have this value also 1 by 12. Then we have at interior, means for this we have 1 by 16. We have 1 by 16. We have to find WU into below. You can see the coefficient shall be multiplied by the total design load and effective span. So total design load means WU into L. This will be total design load. And multiply by span means WU into L. So it will be WU into L square. This was asked once and student not in position where these values are given. So this is here total design load and effective span. Then we have due to live load, we have 1 by 10, we have 1 by 10. And then we have inside 1 by 12, 1 by 12. And these values we have for span moment. Now you go for support moments. So end support we are always assuming that is end support we have simple. So moment we have for end support 0. Now for intermediate, so we have due to dead load. So that is given at support next to end support. This is end support next to end support. We have due to dead load minus 1 by 10. We have same for this minus 1 by 10. And then intermediate means we have this support, that is support C. If I will mention A, B, C, D, E. And then for C, we have this value minus 1 by 12. And for live load, that is imposed load, you can say. So we have this all, we have minus 1 by 9. Minus 1 by 9. And then likewise we will get this. So average we are saying, so WL square by 9 for this and WL square by 9 for this, and then we have to add this, and that we are saying as average. Now go for shear coefficients. So you can see this if we will draw again the same diagram. So we have 1, then we have 2, and then we have 3. And then again we have, that is for dead load. So you can see dead load at end support. We have this will be 0.4. We have 0.4 on this side. For imposed load at end support, so we will go, then we have outer side at support next to end support. Outer side. So we have this will be outer side, means on this side we have 0.6 outer side, and inner side we have value that is equal to 0.5. Same over here, we have this value 0.6, and on this side we have 0.5. And then at all interior, so we have this value 0.5, we have this value 0.5. And then for live load, we have this will be 0.45, and all other values we have 0.6. So all 0.6. So you should be in position to show if external examiner asks you for this, and at end we have 0.45. So likewise we have to use it. These all tables and all this given on page number 36. Then critical coefficient. So this generally asked where we have critical coefficient. So critical shear we have to find, that is clearly mentioned. You can see this. So in last slide actually we have critical sections for moment and shear. So clause number we have 22.6, and that they have mentioned. The shears calculated at the face of the support shall be used in the design of the member at the section except 22.6.2.1. And then we have given over here, that is at a distance d from the face of the support. You can see we have face of the support over here. And at section D, we have critical section for shear. Here also you can see we have intermediate support. Then from this, we are going to consider at a distance d from face of the support. So that is clearly mentioned over here. That same shear as that calculated at distance d, here less than d from the face of the support, we are going to consider whatever value we have at a distance d. These diagrams are given on page 37 and mentioned figure 2. You can see below over here. So they have mentioned figure 2, typical support condition for locating factor shear force. So these are some clauses which we have for IS 456 plain and reinforced concrete. So thank you.